So earlier today we did the customer's realistic TRC1005. So now we're going to look at the one I bought on eBay for 20 quid. Now, will it have the same dry joints? Will it be an easier fix? Will I be able to find the adapter? I'll be able to find the adapter because it's on the roof aerial. I've ordered a couple more of these off eBay. I can't get them from my wholesaler, and this one actually came from Tandy, so it shows how long I've had that. So we'll plug that into the antenna socket, plug that into the power socket. The radio's powered up. It says battery low. I've had this on these before, and it means there's a dry joint on one of the power regulators. So when it goes, it's not going to go into transmit whilst it's playing that game. It really isn't battery low, but it thinks it is because the power rail's missing. So it's going to do all the hissing, I'm absolutely sure. It is, but you can tell it's what you'd call motorboating, as if it hasn't got enough power. So let's see whether it actually receives. So let's put the frequency counter on. 2779125. Let's put 100 microvolts on. No. Right, it's time to open this one up. So it's a screw that goes right through. It's a screw underneath. Put the soldering iron on to unsolder the speaker. So it's in nice condition. So will it be one shield plate to take off, two shield plates like the previous one, or all three? So we'll just have a little look and see whether there is a blatantly obvious topside dry joint. Now the customer's one this morning, everything looked absolutely perfect, but when I did resolder the perfect looking through board links, the radio came into life. We can do this one from the top side and just see. Just do one or two of these ones which we can do from the top. There's a notorious one down here. And that's, I think, where our 7-volt regulator lives. Yeah, that is the 7-volt regulator for the receive. So if this is a dry joint, it'll do exactly what we're seeing. There's another one there. But they all look perfect. So that's the 1, 2, 3, 4. There's another one here which wouldn't do what we're suffering from. It's part of the receiver. So it would be dodgy on receive rather than what it's actually doing. So I'm going to power it back up and we'll just see whether we've hit it, because if that was the case, that'd be fabulous, wouldn't it? No, we haven't hit it. So I've got to take it out and go down the next level. It could be that the 7-volt regulator's up the spout, it's always possible. Just take the PTT out. It's best to do it that way, so we don't lose that little pip in the middle to activate the light in the display. And then we have to have the fun of oh my goodness, look at the rust. see how wonderful it looks, but it's been very wet. But it doesn't seem to be on the board. Ah, it has. It's full of water under the VCO. I'll just put a plus there so I know which way I went. Okay, so it's had the dodgy weather at it. So we need to take the telescopic aerial out. Well, I'm surprised it does as much as it does do, you know, considering it looks like what the Titanic looks like at the bottom of the sea with rusticles. Let's just zoom in on that so you can all see. So the telltale was the rusty sides. And then we come to that shield plate and all that corrosion in that area. But there doesn't appear to be any anywhere else. It's weird, isn't it, that? Has it gone in through the I wonder if it's been left kind of like that and it's dribbled in through the where the strap goes. Anyway, it's happened. So we've got to remove this shield plate, which isn't much of a laugh. I'll pause the video whilst I remove this shield plate. You don't want to watch me unsolder that. Okay, so when we look at this now, without the shield plate, we're very, very lucky. if I can see on the video where I am. Yeah. So most of the damage we should just be able to. I'll get the grinder on that. We'll just grind away some of that metal. So what we'll now do is to get the isopropyl alcohol out and Mr. Chippy's toothbrush and see whether we can remove that. I expect it's been shorting out the 7-volt receive rail. I thought it was going to be all under the phase lock loop here, and there's always the possibility the set could have been a write-off. But in fact it's only affecting 3 tracks. One, the earth, that might be the same bit of earth, and that. Now I was struggling to get this to go. We'll keep going at it. Could always put it in a ultrasonic cleaner if I had to. Let's have another go. We've been able to clear this track perfectly. I mean, obviously I can scrape away at this, but I'd rather just do it with the chemical and the brush. Give it another one. I think that's as far as we're going to be able to do it with that. We're not quite there. So very carefully we use one of the ceramic tools . We've done it. It's clear. And it doesn't appear to have rotted away the printed circuit board. I bet those geniuses at the Apple Centre couldn't do that. Right. Check for continuity. It's fine. So really we should be waiting for this to dry because it's it's going to cause other types of malfunction while it's damp. It does dry pretty quickly, but I'm going to just see whether we can get it to power up now. Put the camera back to its normal position. Switch on. And it still says battery low. Now, what may have happened is that we've got that short circuit has caused the voltage regulator to fail. So the voltage regulator, I think, is that one there. So we'll look at the manual. But if I hadn't have taken that bottom off and then the shield plate, we wouldn't have seen that. And even if the regulator had failed, we could change the regulator and then burn out the new one. So it's there, it's IC5 in the circuit. And IC5, Mr. Chippy's come to see me. Oh, he's been playing with some DMR radios. Do they squawk to each other? That's wonderful. You want to pass me a DMR radio? And I'll squawk to you in another room while we're on this video. This is going to be a forthcoming attraction, folks. I see. G0 OGF receiving.
Roger that. You don't sound much like a Dalek, but there you go. 2 FKC out.
G0 OGF out. Oh, we're going to play Scratchy Corner with DMR. Thank you, Mr. Chippy. Yeah, before it gets soldered. That was a guest appearance from Mr. Chippy. So IC5 is there. So yes, it's that one. So let's see if we can... Oh, it's under that shield plate, isn't it? Just see if I can bend it back a bit and get the prods underneath, but I somehow doubt it. It'll be another of those shield plates off. So turn it back on. It's got full rail there. So I've managed to get that on the input pin. I've got nothing coming out. So I think it's been shorted out. What we'll do, pause the video while I take that shield plate off. Right, switch it back on. And find where we are. Looks to be there. Yes, that's our rail voltage. That's 0. That should be 7. And it is 7. Right, I'm going to have another look for dry joints. We'll look on the other side and then we'll take it from there. Right, so that's unsoldered the crystal, taken the nasty glue off it, put it back in, and the problem's gone away. So it's one of those situations where that glue that can go conductive probably has done in this case. So set up the VCO. Put this channel display module back. Switch on. Transmit. On frequency. What power we're doing. A good 3 watts. Let's see what we can do. So it is 3 watts. So we'll just run through the transmitter. We managed to get 4 out of the customer set. I know I haven't got the screen plates back on, so we'll just run through this. So peak, fraction more there. If you remember, the limit spec is 3 watts, the nominal spec is 3.5 watts. Just see if we can, if the trimmer there is correct. Bring that up a bit. We now need the white trimming tool. So at 3.5, 3.8, peak that, and then drop that. So this one, it will actually do 4.5, which of course will thrash the batteries. There we go, 4 watts. So what's it doing on low power? Should be 0.4 watts. If anything from 0.15 to 0.4 is okay. This one is doing 0.25, exactly like the customer's one did. So we've got 4 watts out of it, we've got 0.4 out of it. So that's transmit. What about deviation? Let's have a look at that. Wallow, 1 2 1 2. Wallow, wallow. It's actually spot on. So the preset resistor there doesn't need adjusting. It's spot on at 2.2 to 2.5. So now we'll look at receive, and let's go over to there. So I'm glad the water damage hadn't actually knocked any components out. It's just a combination of dry joints. I've got that loose earphone socket to deal with. We'll put this meter away, we're done with that. We're going to field test this one, Mr. Chippy and I have decided. I think since we've been editing it the way I have been editing it, we haven't done one of these, so we may as well see if we get the 6 miles or whether it's a white elephant. Right, receive. So at the moment, we'll switch the equipment on. Let's look at what we're getting on the cyanide meter. So for 12 dB, we are at 1.4 microvolts, which is pretty lousy. So these aren't that sensitive, but they're also, I don't think, that deaf. They work on 10 dBs when I find it. Yes, for 10 dB, let's move it to 10. There's 10. We're getting 1.2 microvolts. So that is a fail, because 1 would be the worst they want you to have. So what we'll do is we'll start off. Did I put that? I didn't, did I? I did not put that tool back. They're like hen's teeth, those. By the time you've imported those from the States, about 20 quid a set. So, let's go through the receive. It's that one you never touch because it's transmit second harmonic. We need to do the detector, which is there. Let's just check that one out first. So I'm going to put an S9 equivalent signal of 100 microvolts on. We'll have a look at the oscilloscope. Turn the bench light off so we can see it. And set ourselves to a volume level which is sensible. I've made a tiny adjustment there, but that won't make any difference to the reading. So back to the cyanide meter. Let's go through this receiver. So we'll put a much smaller signal on now. How about there? About 4 decibels. No improvement there. No improvement I can see there. Possibly a minute one there. And then our other receive one is there. We do have an improvement there. So as long as we can get it over the minimum. So we'll just check these again. We've now got an improvement on that one. Now I've set that one. As I said before, these are crystal filtered as standard. Just check with a higher signal on this one. And then back to the small signal. That's as good as we're going to get it. So here's the moment of truth. Can we get... Yes, we can. We're in spec. Only just. So there's 10 dB and we're at 0.95 of a microvolt. So for 12 dB, the not so impressive 1.15 microvolts. So ours doesn't work as well as the customers. That really doesn't matter at all. It is in spec. And remember, this is a signal to noise ratio. So although we want the best possible cyanide, it doesn't mean that the thing's actually deaf. It means it's noisy. So, you know, the two are linked. It could be because it's deaf, but it probably isn't. So what we now do, let's look at the attenuator. So as we were saying, it's 1.15. So let's see how far we can hear it down to. Well, there's 0.3 of a microvolt, and we can still hear it. You can hear it down to about 0.2 of a microvolt. Now the other thing we need to check is the squelch actually works. So let's look at the sensitivity of the squelch. It's coming in at 0.95 and it's leaving at 0.7, so that's alright. They're a bit clunky on these sets. Now we need to look at the maximum squelch. And although this isn't adjustable, I'm just checking this. Yeah, that comes in at 3 microvolts. You've got to remember it's a hand portable, so it doesn't have the strongest squelch in the world. So there we are, we're actually done. So the actual repairs, all the shield plates off, all the dry joints, chemical cleaning and resoldering, the water damage, Everything else was fine. I've had to take the crystal out and I've put it back in again, having removed the possibly conductive glue. So what I'll now have to do is to put all these screen plates back. Then as I put each one back, I'll retest the radio, and then we'll put it on the air and not hear anybody. So we're all back together, and 19 Roger. As I've said before, these people will be 28 to 30 odd miles away. So we'll go through like we do. So when it's not raining, we'll do a field test on this. We're not doing an on-the-air test. We know what these sound like. So there you are, all sorted out. That's my £20 purchase off eBay, complete with a carrying case, but about 3 hours to fault find it, but no actual part cost. So thank you for watching the realistic TRC1005 from 1983.